Okay guys, let me go ahead. I'm looking at slide 13 on the stoichiometry PowerPoint, which is still in the mole to mole conversions and ratios. So let's take a look and see how this mole ratio is going to impact us. If you're looking at slide 13, I realize part of the equation is missing, so this is what that balanced chemical equation should look like. And then right below it says how many moles of NH3 could be produced if the reaction started with 6.00 moles of N2. And the steps there tell us write the equation. Okay, I've done that. Identify what you know and write it down. And again, that's that given in the problem. So the given in the problem is that 6.00 moles of N2. And this is where it really becomes important for you to write down the units and what compound those units go with, what we're referring to here. I'm going to go and make my T-chart. If you continue reading, it says how many moles of NH3. So the answer should end up being in moles of NH3. That's what we're trying to figure out. And then it says line up conversion factors to get to the unknown. Well, think about this for a second. What have we been talking about in the previous two video tutorials? We've been talking about how to go from mole to mole. And what do you use to go to mole? You use a mole ratio. So we're going to do exactly what we've been doing here. We got to drop these units down. And again, when you drop these units down, I would strongly encourage you to write them out. Moles of N2 is dropping down here. Now, when you look at this, we've got mole over mole. Guys, when you see mole over mole, that is telling you that you need a mole ratio. And when you need a mole ratio, what are we looking at? You should be looking at the coefficients, which is exactly what we were doing previously in those video tutorials. So now look back up at your balanced equation. How many moles of N2 are in this equation? Well, we don't see a coefficient there, so we know that that's a 1. How many moles of NH3 are present? 2. And now we would multiply straight across. 6 times 2 gives us 12. Pay attention. How many sig figs do you have over here? We have 3 significant figures, which means our answer should also be in 3 significant figures. And here's how we would kind of think about this. If we started with 6 moles of nitrogen, 12 moles of NH3 or ammonia could be produced. Okay, and if we were to look back, we see that moles of N2 cancels out, and then that's what we're left with. So not a difficult concept at all. If you keep watching, I'm going to go over a couple more of these.